Have you ever stared in an integral and thought, but what if I told you that behind every complex looking expression is a method, a pattern, a key to unlock a solution? In this tutorial, we're diving deep into the four powerful tools of integration. First, the logarithmic integration, trigonometric transformation, inverse trigonometric integration, and the integration by parts. But before we dive in, hi, I'm Hart and I'll be your guide as we explore the core ideas of integral calculus. Whether you're viewing for a test or learning this concept for the first time, this tutorial is made for you. So grab your notebooks, take a deep breath, and get ready to master the math. So for our first topic, we are going to talk about the logarithmic integration, which involves the integral of the form, the derivative of du all over u, which results to the natural logarithm plus c or d constant. So this technique is very useful, especially when the numerator is the derivative of the denominator. Also, sometimes we may also need to use the algebra or the partial fraction to simplify first the given equation. And now, let's go on to our examples. So for our first example in logarithmic integration, we have the derivative of 1 all over x dx. As we can observe, the derivative of x or the denominator is 1, which is our numerator. So we can already know that this is a logarithmic integration. So our first step, let's use the u substitution. Let's let u is equals to x and du is equal to dx. So let's write it from the formula. The derivative of du all over u is equals to ln u plus c. So this is equals to ln x plus c. So this is our final answer. So this example is the same, the integral of 6 all over x dx. So let's do the same steps. Let's use the u substitution. And then, let's separate the constant or the 6 and use the formula for logarithmic integration. So this is our final answer. So for our second example, we have the integral of x squared all over x cubed minus 8 dx. So again, let's use the u substitution. So let's let u is equals to x cubed minus 8 because as we can observe in the problem, when we derive this, the derivative will have an x squared, which is our numerator. So the du is equals to 3x squared dx. So let's just divide the 3 both sides so that we can cancel the 3 and make our numerator du. So let's separate the constant and write the formula. And then, we write the u to x cubed minus 8 and add the c or the constant. So this is our final answer. Number 3. The integral of x squared plus 4x plus 3 dx all over x plus 2. So as we can observe, the numerator is greater than the denominator. So in this case, we can use the long division first before we integrate because we don't have a direct formula for this. So, let's divide x squared plus 4x plus 3 to x plus 2. So let's rewrite our expression to the integral of x plus the integral of 2 minus the integral of 1 all over x plus 2 times dx. Here, we can use the power rule plus the integral of 2, which is 2x, and this one is the natural log. So let's use the u substitution. So this is our final answer. Next, the number 4. So the integral of 5x plus 7 all over x squared plus 3x plus 2 dx. So in this case, we can't use the long division because the numerator is not greater than the denominator. But we can factor the denominator. So in this case, we're going to use the partial fraction. So, 5x plus 7 all over, what is the factor of this? X plus 1 times x plus 2, right? So, let's prove this. X squared plus 2x plus x plus 2. When we simplify this is equals to x squared plus 3x plus 2. The same as the denominator. In partial fraction, the first step is we are going to equal this to a all over this one plus b all over this one. So for us to cancel the denominators, we have to multiply x plus 1 times x plus 2 on both sides. So let's cancel this out. 5x plus 7 is equals to, cancel the x plus 1, we have the remaining x times x plus 2, and cancel the x plus 2 to get b times x plus 1. Our next step is we are going to think of what value of x can cancel a or b. If we let x is equals to negative 2, we can cancel this out. So, 5 times negative 2 plus 7 is equals to a times negative 2 plus 2, which is equals to 0. So this is cancelled. Plus b times negative 2 plus 1. So negative 10 plus 7 is equals to negative 3. This is also equals to b times negative 2 plus 1 is equals to negative b. So, divide both sides by negative 1 to cancel the negative sign. So b is equals to 3. And to cancel the b, we can let the x is equals to negative 1. So, 5 times negative 1 plus 7 is equals to a times negative 1 plus 2 plus b times 0. So this is cancelled. So, 5 times negative 1 plus 7 is equals to 2, which is also equal to negative 1 plus 2 is equals to a. So, a is equals to 2. So our next step is to change or put the values that we got. So, let's substitute. 2 all over x plus 2 plus 3 all over x plus 2. And let's put the integral. And then, one by one, let's start with the integral of 2 all over x plus 1 dx. So let's let u is equals to x plus 1 and du is equals to dx. So this is now a logarithmic. So 2 ln x plus 1. And this is the same as the b. So 3 ln x plus 2 plus c. So this is our final answer. Again, let's not forget the c or the constant. So next, the number 5. So the integral of dx all over the square root of x times 1 plus the square root of x. So in this case, we need to let u is equals to the square root of x. And we need to let f of x with respect to u. So x is equals to x squared, and the dx is equals to u du. So let's substitute our values to the equation. So the integral of 2u du all over our square root of x, that is now the u times 1 plus u, since we let the square root of x is equals to u. Now this is equals to, let's put 2 outside the integral. So du all over 1 plus u. So we can use now the formula of logarithmic integration. So 2 ln 1 plus u plus c. Since our value of u is square root of x, let's change the u. So the final answer is 2 ln 1 plus the square root of x plus c. So for our second topic, we have the trigonometric transformation, where we have 4 cases. So the first case is where n or m is a positive odd integers. So in this case, we can use the identities of cosine square x is equals to 1 minus sine square x, and sine square x is equals to 1 minus cosine square x. So for our second case, where n is a positive even integer. So in this case, we can use the identities of secant square x is equals to 1 plus tangent x, and cosecant square x is equals to 1 plus cotangent x. And for our case 3, we have where n is an integer. So in this case, we can use the identities of tangent square x is equals to secant square x minus 1, and cotangent square x is equals to cosecant square x minus 1. And then, for our fourth case, or the last case here, where m and m are positive even integer. So in this case, we can use the power reducing formula, or this one. And now, let's go on to our examples. For our first example, the integral of tan cube x dx. As we can observe, this is a case 2. Our n here, or the 3, is an integer. So we are going to use the trigonometric identities to simplify the first equation. So let's rewrite the equation. The integral of tan square x dx, so that we can simplify the tan square x. Tan square x is equals to 1 minus secant square, right? So let's multiply the tan x to the inside parentheses. So the integral of tan x secant square x minus the integral of tangent x dx. So now we can use the u substitution. The derivative of tan x is the secant square x. So this will become 1/2 tan square x. Since we use the power rule, n plus 1 all over n plus 1 minus the integral of sine x all over cosine dx. Because tan x is also equal to this one. So that we can use the logarithmic formula. So we have the ln secant x plus c. Because the 1 all over cos x is equals to secant x. So we have our final answer. For the number 2, the integral of sine square x cosine to the 5th power x dx. So this is the case number 1, where m and m are positive integers. So m is equals to 2 and n is equals to 5. So if we have a problem like this, we need to split the even integer into 2, even and odd, so that we can simplify. Let's split the cosine to the 5th power x into cos to the 4th x d cosine x. So let's make this into cosine square x squared. So we can simplify into identities, the cosine square x. So let's rewrite this into the integral of sine square x times 1 minus sine square x squared cosine x dx. So let's expand this factor. One minus sine square x squared. And then, let's multiply all the terms with each other and put integral in each terms. Now, let's apply the u substitution. Let u is equals to sine x and du is equals to cosine x dx. U squared du minus 2u to the 4th du plus u to the 6th du. Next is the power rule to integrate. So, 1 all over 3 u cubed minus 2 all over 5 u to the 5th plus 1 all over 7 u to the 7th plus c. And for the last step, we change the value of u to sine x. So for number 3, the integral of tan to the 5th power x times secant to the 4th power x dx. As we can see in the cases, this is a case number 3, where n is a positive even integer. For our first step, we can split the secant to the 4th power x into secant square x times secant square x. In this way, we can use the u du technique for us to cancel the other term. So let's let u to tan x and du to secant square x. So this is now the integral of u to the fifth power times second square x du. We have the second square x. So what we are going to do is to use the identities to integrate this one. So we know that secant square x is equals to 1 plus tangent square x. And this is equals to 1 plus u squared. Now, let's rewrite our equation. The integral of u to the fifth power times 1 plus u squared du. And we multiply this, so the integral of u to the fifth power plus u to the seventh power du is equals to the integral of u to the fifth power plus the integral of u to the seventh power. Using the power rule, we can now have our final answer. 1 all over 6 u to the sixth power plus 1 all over 8 times u to the 8th power plus c. And now, we can substitute the value of u. So this is our final answer. Our fourth problem is the integral of sine cube x times cosine cube x dx. Again, let's rewrite first our expression. Here, we know that the sine square x is equals to 1 minus cosine square x. So let's rewrite our equation to the integral of 1 minus cosine square x times cosine square x times sine x dx. We can now use the u substitution. So let u is equals to cosine x and du is equals to negative sine x dx. Which is already at our equation. The only thing that is missing is the sign. So, the integral of 1 minus u squared times u squared du. Now, this is easier to solve. So, negative integral of u squared minus u to the fourth power. We can just multiply u squared by u minus u squared. We can now use the power rule. So, negative 1/3 u to the third power. So, negative plus negative, positive 1/5 u to the fifth power plus c. And let's substitute the value of u to get our final answer. So, negative 1/3 cosine cube x plus 1/5 cosine to the fifth power x plus c is our final answer. And for our last example for trigonometric transformation, we have the integral of sine to the fourth power x times cosine fourth power x dx. We can observe that this is a case 4, where m and m are positive even integers. So we will use the power reducing formula. So first, the sine to the fourth power x. So this is equals to sine square x squared. which is equals to 1 minus cosine 2x all over 2 squared. This is equals to 1 minus cosine 2x all over 4. And then for cosine to the 4th power x dx, this is equals to cosine square x squared, which is equals to 1 plus cosine 2x all over 2 squared, which is also equal to 1 plus cosine 2x all over 4. And now, let's multiply these two. So this is equals to 1 all over 6 times 1 minus cosine 2x squared times 1 plus cosine 2x squared. And so this is equals to 1 all over 16 times 1 squared minus cosine squared 2x squared, which is equals to 1 all over 16 sine to the 4th power 2x, which is equals to 1 all over 16 times the integral of 3 all over 8 times 1 half cosine 2u. Now we'll let u to 2x. So our du is 2 dx. So now we have 1 all over 16 times the integral of 3 all over 8 times 1 half cosine 2u plus 1 all over 8 cosine 4u. And this is equals to 1 all over 16 times the integral of 3 all over 8 times 1 half cosine 4x. Plus 1 all over 8 cosine 8x. And then 1 all over 16 times 3 all over 8x minus 1 all over 8 sine 4x plus 1 all over 64 sine 8x. And now, let's multiply 16. So our final answer is 3x all over 128 minus sine 4x all over 128 plus sine 8x all over 1024 plus c. In this section, we are going to focus on the integrals that results in inverse trigonometric functions. In this topic, we only have two formulas, which are the integral of du all over the square root of a squared minus u squared is equals to arcsine u all over a plus c. And then the second one is the integral of du all over a squared plus u squared is equals to 1 all over a arctan u over a plus c, or the constant. So now, let's walk on to our examples. For our first example, we have the integral of dx all over 16 plus x squared. What I always do when a problem is inverse trigonometric, first thing I do is to identify the values based on the formula. So our a is the constant. So a squared is equals to 16 and a is equals to 4. And our u squared is equals to x squared and our u is equals to x. So our du is equals to dx. So now, we can turn the values into the formula. So our final answer is 1/4 arctangent x all over 4 plus c. For our second example, the integral of dt all over the square root of 5 minus 16t squared. Again, let's identify first the values. So a squared is equals to 5. So our a is equals to the square root of 5. And u squared is equals to 16t squared. So our u is 4t. And our du is equals to 4 dt. We are going to divide both sides by 4 to get our dt. Now, let's substitute the values. So 1/4 times the derivative of du all over the square root of 5 minus 16t squared. So this is equals to 1/4 arc sine 5t. So this is equals to 1/4 arc sine 4t all over the square root of 5 plus c. For our third example, the integral of sine x dx all over 5 plus cosine square x. So to simplify, we'll let u equals to cosine x to cancel the sine x in the numerator. So our du is negative sine x dx. So we divide the both sides by negative 1 to cancel the negative sign. And then, negative integral of du all over 5 plus u squared. And now, we can use the step of getting the values a squared is equals to 5 and a is equals to square root of 5. So our x squared is x squared. So our x squared is equals to u squared. And our x is equals to u. Now, we can substitute the values. 1 all over the square root of 5 arctangent u all over the square root of 5 plus c. And we substitute the value of u. So the final answer is negative 1 all over the square root of 5 arctangent cosine x all over square root of 5 plus c. For number 4, the integral of x times x squared plus 4 dx all over x to the 4th power plus 9. First thing is to simplify the numerator because we don't have a direct solution for this. So, the integral of x cubed plus 4x dx all over x to the 4th power plus 9. We separate the two terms here. So, the integral of x cubed all over x to the 4th power plus 9 dx plus the integral of 4x all over x to the 4th plus 9 dx. And then, let's let u the two terms to get their answers. So u is equals to x to the 4th power plus 9. So our du is equals to 4x cubed all over 4 dx. We got du all over 4 is equals to x cubed dx. And u is equals to x squared. So du all over 2 is equals to x dx. So we got du all over 2 is equals to x dx. And let's simplify. And let's apply the values. So, 1/4 times the integral of du all over u plus 1/2 times the integral of 4x all over u squared plus 9. Then, this is now 1/4 ln x to the 4th power plus 9 plus, here we can apply the formula of inverse trigonometric function, plus 2 times the integral of 2x all over u squared plus 9. So let's let a squared is equals to 9, a is equals to 3, u squared is equals to x squared is equals to u squared, and x is equals to u. So, 1/4 ln x to the 4th power plus 9 plus 2 times 1/3 or 2/3 arctangent. Our u is x squared, so this is x squared all over 3 plus c. So for number 5, we have the integral of sine x times cosine x plus 4 all over 1 plus cosine square x dx. So first, let's simplify the numerator. So sine x times cosine x plus 4 sine x all over 1 plus cosine square x. So this is equals to the integral of sine x times cosine x all over 1 plus cosine square x plus the integral of 4 sine x all over 1 plus cosine square x. Now let's let u the equations. So this is equals to negative u du all over 1 plus u squared plus negative 1 the integral of 4 du all over 1 plus u squared. And then, let's use the power rule to the numerator. The second one, a squared is equals to 1, a is equals to 1, x squared is equals to u squared, and x is equals to u. So, for arctangent, u all over 1 plus c. So, our final answer is 1/2 ln 1 plus cosine square x minus 4 arctangent cosine x plus c. And for our last topic, we have the integration by parts. This technique is used when we integrate a product of a function. So our formula is the integral of u dv is equals to uv minus the integral of v du. So now, let's go on with our examples. So for our first example, in integration by parts, we have the integral of x e to the x power dx. So let's get the values. So u is equals to x, du is equals to dx, and dv is equals to e to the x dx, and our v is equals to e to the x. And then, let's apply it to the formula. So this is equals to our u, which is x, e to the x minus the integral of e to the x dx. So this is equals to x e to the x minus e to the x dx, since the integral of e to the x is also e to the x. So for our number 2, the integral of x ln x dx. So again, let's get our values. So let u is equals to ln x, du is equals to 1 all over x dx, dv is equals to x dx, and our v is equals to 1/2 x squared. And now, let's apply it to the formula. So this is equals to ln x times 1/2 x squared minus the integral of 1/2 x squared times 1 over x dx. And now, let's integrate. So this is equals to x squared all over 2 ln x. So this is equals to x squared all over 2 ln x minus x squared all over 4 plus c. For our number 3, the integral of x squared times cosine x dx. So again, let's just get the values. U is equals to x squared, du is equals to 2x, dv is equals to cosine x dx, and v is equals to sine x. So now, let's apply it to the formula. X squared times sine x minus the integral of sine x to x. Since we can integrate the sine x to x dx, let's do the same process again. So this is now x squared times sine x minus 2x times cosine x minus the integral of 2 cosine x dx. So this is equals to x squared times sine x minus 2x times cosine x plus 2 times cosine x plus c. For our fourth example, the integral of ln square x dx. So let's get the values. U is equals to ln square x, du is equals to 2 ln x all over x dx, dv is equals to dx, and v is equals to x. And then, let's apply this to the formula. So x ln square x minus the integral of x times 2 ln x all over 2 dx. And then, x ln square x minus 2 times the integral of ln x dx. Since we can't integrate, we do the same thing. So let u is equals to ln x, du is equals to 1 all over x dx, dv is equals to dx, and v is equals to x. So, x ln square x minus 2 times x ln x minus the integral of x times 1 all over x dx. So this is equals to x ln x minus x plus c, or x ln square x minus 2 times x ln x minus x. So our final answer is x ln square x minus 2x ln x minus 2x plus c. And for our final example, the integral of e raised to x times sine x dx. So again, let's first get the values. So u is equals to sine x, du is equals to cosine x, dv is equals to e raised to x dx, and our v is equals to e raised to x. And again, let's apply this to the formula. So this is equals to sine e raised to x minus the integral of e raised to x times cosine x dx. Here, let's integrate the integral of e raised to x cosine x dx. And let's do the same thing. So this will become sine x e raised to x minus e raised to x cosine x minus the integral of e raised to x times sine x dx. And next, since the integral is the same as the given, we will equal these two. So, the integral of e raised to x times sine x dx is equals to sine x e raised to x minus e raised to x times cosine x minus the integral of e raised to x sine x dx. And then, let's combine the two. So, 2 times the integral of e raised to x sine x dx is equals to e raised to x sine x minus e raised to x cosine x. So for us to cancel the 2, we need to divide both sides by 2. So, this will become the integral of e raised to x sine x dx is equals to 1/2 e raised to x times sine x minus cosine x plus c. And this is our final answer. Thanks for watching. I hope this tutorial has helped you clarify the techniques of integration. Keep practicing, and soon, these methods will feel second nature. Good luck with your studies!